I'm probably one of the most unlikely person to be invited to talk about design modeling and digital technology because I'm first of a generation before CAD started in Europe. So I arrived about a year before CAD started, and I'm talking 2D AutoCAD. So I'm slightly out of sync with the period, and also I've been sort of spending my whole life trying to build projects and building them with the technologies available at the time. However, I scratched my head. So I've started working with Peter Rice in Europe, and that was quite a good start in a way to do extraordinary things, or at least to get a chance to do a few extraordinary things. So that's early projects. And then sort of 28 years later, I've done quite a few other things, but it's unfortunate that the world moved on from a period where structure was architecture. And now it's pretty much not the case for most people, and structure is just something that has to be. The unfortunate thing that has to hold a building, but please not be seen for most architects at least. And as I was preparing the talk, I came across a very old piece of text by Ovarup, which is, it was a christening of his first computer. He wrote a poem for the christening of his first computer, and I finally got it only on Friday. And on Friday, I read the poem and got deeply depressed, because actually this is dated 67, and he says it all. I could read you the poem, and probably it would be a better talk than what I'm going to tell you now. So it's very depressing, but that is who created that firm, Arup, and he was a thinker almost as much as an engineer, and always sort of thinking of the implication of what he was doing. Does digital necessarily pass through the question of structural innovation, or does it actually sort of possibly pass through slightly easier methods first? And probably, I would say that at this point in time, it's going to be more trying to do either similar things or push them a little bit than actually innovate as far as what we've already seen, and as far as you will probably see for the rest of the day and the next 2 days as well. And as I was preparing again, I came across this quote from Jan Noetling, and I thought that was quite a good one. Now, if gravity is a boring force, that may lead to boring solutions, or at least solutions that don't need to evolve that much, because gravity itself is not evolving that much. So that is quite a question. So as I was sort of mulling over again sort of ideas, and this is the sticker, I was on the train after the phone call, I sort of jotted down a few things. This is the only French piece of the presentation. I've actually then developed the presentation over a period of about 6 months, and realized that when I got back to that sticker, I was pretty much there or thereabout. But I've enlarged the topic slightly to the sort of digital use of tools and methods in construction rather than purely structural engineering. However, I'm a structural engineer, so you'll see a lot of structure. The question of the adoption of technology in engineering, and in structural engineering in particular, is something that is really absolutely topical, is of the moment. There is a sort of explosion of interest in the question, and this is only a few titles of talks that have happened in Europe in the last 6 months, I would say. So people are really looking at those questions and wondering what will happen. Will computer redesign the designer? Will the man still be alive? You know, should we not adopt these things, and to what degree? In structural engineering, the sort of technologies we're looking at are those on the slides. You know, stage analysis, parametric design, rule-based design, optimization. I mean, you've heard those words. Coding as well is a sort of fairly recent, I'd say a few years that it's really trickled into what we do more day to day, with various tools that have sort of emerged. However, we don't yet design humans very well, and this was supposed to be a video, but we had a bit of a crisis with the videos, so you'll forgive me with those. And we are still sort of, I hope, the sort of innovative force behind what these tools will be doing. And I believe this is extremely important that we don't forget that. In the construction industry, and more in the construction phase, the tools I showed you earlier were those about design, the tools we use in design. But in the construction phase of our projects, there's another series of tools that are sort of emerging as well. Robotics, we've already seen it. Slightly more far-fetched is probably drone installation, 3D printing, laser cutting, CNC, which has been there for a long time, actually. So some of them have been there longer than others. And that was a robot video, which is installing little pieces of wood and stacking them. Personally, it's not a very impressive video, so there's no problem that you don't see it as a video, because all it is doing is picking the pieces of wood from one end of the room and moving them into an arrangement in another part of the room. However, this technology seems to be able to occupy a whole room and move in a whole room, which is one of the first problems of robots, is that they're often on tracks, they're often limited length. This one is a cable-based system and is quite an interesting potential. At the moment, what it's doing is very limited, but it is being tested in a pavilion and in an installation in our office in the next few weeks. And we'll see what it works. What this one does, it also knows when he's dropped something, or then it hasn't put it the right way around. But new technologies are often all about hype. And if you look at this, it's not from me, it's a new civil engineer who produced that diagram, and it had more technologies in it. But it sort of shows a sort of evolution before the adoption of the technologies. And you may see that BIM in design and build is now maybe towards the path of adoption, but BIM in asset management is still on the innovative trigger. And I think you will see a lot of technologies in the next few days which are at various steps of that curve. So how does that tie in with the industry challenges? Because after all, we're not doing this just because we want to have fun. We are doing this for constructing things, constructing buildings, and the construction industry has got quite a lot of challenges on its hand. We've heard already some of them, and in a way, Olivier did a quite beautiful introduction about the issues of resources and so on. People resources are also a problem. There's not enough engineers, there's not enough specialized skills craftsmen to build things that we would like to build. Brownfield site, it's rarer and rarer that we build on a greenfield site a new building. We're more and more modifying buildings, demolishing them, but of course there's tons of stuff in the ground that stays. There's all sorts of aspects which are evolving at the moment in terms of what we do. Resources, limitations, productivity is another one of the construction industry bugbears. And that is a big debate, actually, whether more productivity is required or not, whether we should build more or not. But there is a growing demand just because of growing population. Therefore, it might be good if the construction industry was actually a bit more efficient, a bit more speedy at building its building. But where will this all go? Or where is it at the moment, in a way? Is that where we're going to go? And that could very well be, because the day the industrial partners of the construction industry seize the tools, they will not necessarily use them in the name of creativity. They may very well use them to create arrangements of building that are more repetitive and that are more, automation could lead to this. So it's a question that will have to be answered and sort of thought of is the appropriate use of the tools and the automations. Again, I got back to OVE, and it's as part of the same computer christening talk, and I think there is a risk. We've seen that happen before, the industrialization of the industry, and the idea of prefabrication offsite is a wonderful vehicle for industrialization as well. So I think there's sort of big questions on what we do next with all of this. And I very strongly believe that the construction industry is not about product. It's a word that has cropped up in our industry, I'd say 10 years ago now, and it's the product we offer and so on. We're not about product, or I hope we're maybe not yet about product, and that we're actually still about places, about events, about experience, about all sorts of other things than just product. So where I see this happening at the moment is probably to try and join forces. Not work separately, not work against each other, but actually join forces with the machines in order to harness the best bits of both the humans and the machines. And again, same talk, 1967. So that tells you that things maybe don't move quite as fast as you might think in the construction industry, or at least that the preoccupations of the humans don't move quite as fast as one might think. So where it's happening in the most interesting ways at the moment is what's happening, I would say, in the craft industries. And that's not the construction. They don't have the same problems of scale that we have. They don't have necessarily to sort of produce in large quantities, and so but they use the tools in very interesting ways. And they do use the tools in favor of creativity as opposed to industrialization and automation. And when we use tools and sort of digital world, you're probably familiar with the work of Grayson Perry and his greatest tapestries. This is done partly with a company called Factum Arte, which is actually a very, very interesting, and I have no shares in them, but a very interesting outfit that actually is trying to bridge the gap between designers and digital skills and mathematics and so on. So there's new roles as well evolving of people who will be able to speak about several disciplines together and sort of enable the creation of works. And this is, of course, for an artist, a very well-known English artist, and therefore there is means and money behind this to make it possible. But it's quite extraordinary what they do. Future of Bespoke. This is already happening in the fashion industry. This is quite an interesting company who's basically you open their website, they have a series of patterns, and you drag your finger and you create all the jumpers you want in the world within that pattern, of course. And that is quite an important factor of the question, is that mass customization is still mass, and is still within a very tight boundaries of patterns. And if you look at cars, you can change the seats maybe, you can change the color of the box. That's about it. And actually several cars with different shapes may even have the same body underneath. So I think there's a question of how much of that we want to try and harness as well. But this is brand new. This is kind of knitting fun. This is where these crafts might go. I am partly interested by Japan and the question of craft, and I think they had an economy of means that was quite extraordinary, probably driven by lack of money at the time, or an economy which wasn't going well. But they created those absolutely amazing fabrics with paper, small tools, rice paste, and silkworm and mulberry leaves. And that is actually really extremely economical in resource, in in sort of badness of the technology. This is pretty sustainable. People were doing it in their homes. It's very very subtle in a way, the way they used the methods and what they customized and what they didn't customize. One of the key things of that industry of the kimono is that the width is always the same. So the width of the panel and the fabric is always the same. So the guys could automatize their tools, their printing boards, all of this, really efficiently. The length is actually always the same. It's about 12 meters by 35 centimeters. I don't quite know when they face people like me, but that's because I probably don't fit in 70 centimeters. But it's that sort of, so they had organized certain things very repeatedly, and other things were extremely creative, but in very efficient means. And so that got me thinking about what the craft of the engineer was. And there is something about the craft of what we do. It's not a craft that is manual. It's not a craft that will necessarily produce objects. It will, in the end, produce objects at the best of times. But what we produce is ideas. We produce interpretation of material, rearrangements of materials. We produce sort of structural solutions. We produce, but this is often slower than one thinks. But one still needs the ideas. One still, none of what we have seen so far has occurred because the machine has decided to do it. Currently, it's the human still in charge of the ideas, and I hope it stays that way for a while. Different projects. So now I'm going to show you a few projects, but not sort of in great detail, so you might be slightly hungry at the end, but we can always talk later in the day. Projects are not pure. What I mean by this, in the use of digital tools, some projects will use them at various phases. So they can be at the early design, generating ideas, generating geometry, or it can be in the construction phase with the robots and so on. But it's not a pure thing. You don't yet have projects where it will occur single-handedly in the digital world, entirely driven by computers from A to Z. And one of the best examples for me is this one, which is Taichung Opera House in Taiwan. And Taichung is generated catenoids in terms of geometry. It's in a highly seismic zone, so it had analysis galore in terms of understanding its behavior and so on. And then it had to be built. And the photo on the other side is them building it. And if you pay close attention, the man who's nearly kneeling is holding a little hammer. Because the way they had to build this geometry was to use, or the way they devised to build this geometry was to use mesh, which of course is porous as a formwork, but that was the easiest thing to deform. And then they poured the concrete, layers of 20 centimeters at a time, not more than that, because otherwise the mesh would burst. And then they couldn't use pokers to vibrate the concrete, so they used an army of men with hammers to actually vibrate the concrete and made sure it would be good quality. So this is a really quite brutal example, and so black and white example of where we are at with digital. We're using it in certain ways, we're using it for certain parts, but there is still plenty of room, and needs to be plenty of room for other methods, or even being still very imaginative in mixing methods. That's actually the rebars of the catenoids. So when you have that density of rebar, you definitely want your concrete to have been well mixed and well vibrated, but that's harder with hammers. Probably in the world of structural engineers, we can design everything in the virtual world. And when I say design everything, it's within the realm of a number of materials, of course, but still you can get the geometry, you can get the layout, you can even generate a layout of column or elements and arrangement. you can calculate it. You can even then draw it and transfer. There's more and more transfers between sort of calculation, initiation of ideas, and sort of production of the construction information. But then you have to build it, and that was a friend of mine who said that to me when we were actually preparing this talk. And I said, well, no, unfortunately. Thank God we are still building some things, because I think that's the most important thing. So, again, analysis in structural engineering is not new. You know, Sydney Opera House, 57, Arup was working with a sort of, Southampton University. So again, university, engineering, working together to develop the software, and Arup was writing their own softwares and has continued writing our own softwares for a long, long time. So, and that's what's, now there's a sort of really trendy thing which is called coding in architecture, in other, and in our industry as well. But coding is probably not much more than writing your own softwares for a certain purpose. I'm going to probably make a lot of enemies by saying this, but I'm actually pretty convinced that writing your own tools or developing your own tools and your own softwares is not something new and is something which is very powerful. So one example where we did that is a Singapore sports hub, which is a 300 diameter sports arena with a movable roof. You see it open right now. It's quite a large structure. It's amazingly light in a way, and for that we use that sort of very crude chart of span to weight per kilogram per cubic meter per square meters ratio, and the sports hub is the star. So you can see that it's actually quite light for its own span compared to many other buildings. And one of the main reasons it achieved that is by using sort of the powers of computers we have now, which we didn't have probably 5 years ago, to do a very, very vast analysis of circa 1,500 load cases, and in particular wind load cases. This is done by using also cloud computing, writing your own softwares, harnessing several computers at once, doing a fantastic sort of wind tunnel analysis, and not just trying to bring it down then to 10 load cases, but actually using the measurements in real time and running about, I think there's about 800 wind cases in this. So when you start to really take the behavior of the wind and not just equate it or smear it or simplify it, then you can really start to knock the weight down, and the results can be quite powerful. But that is not very new in a way. It's using computer power in a better way. It's using the technologies of linking them up, but it's doing analysis, like we have been doing analysis in structural engineering for quite a long time. So it's not generating the idea, it's not, but it is still sort of, it's what we call optimization. So maybe it's doing the same thing but better, as opposed to, and it's also helping the digital workflow. That's a word that has appeared in our midst a few years ago, of actually getting the different steps of the production talking to each other, from geometry generation, parametric modeling, and so on, to analysis, to then sort of creating the sort of construction information. Generating design is a whole other matter, and some people would like you to believe that architecture being entirely rule-based, it could actually be done by machines. And one might argue that actually for housing that might be possible. Whether that's desirable is a whole different matter. But you are still using reasonably regular grids. You still want your floors to be flat, your walls to be flat ideally, and you want the dimension to be sensible in relation to humans and also all the codes that we have that define what a good size for a flat is. So you could probably generate housing layouts with a computer and some coding as well. Whether that's desirable is another matter. When you generate ideas, you often, and I think Romain said it quite beautifully, stand on the shoulders of giants. So you don't generate only new ideas. You look at old ideas, or even sort of fairly recent ideas. And I'm going to talk to you about Sagrada Familia and what we're doing there. But actually, the idea of Sagrada probably occurred with that project of Peter Rice called the Pavilion of the Future in Seville. Seville Expo 92, we're 2017. Actually, nothing as daring as Seville Expo has been done with stone since then, I would say. And so when we were approached by the Sagrada team to help them with some of the construction of their towers, it's the sort of central tower, Jesus, Mary, and the four evangelists, which are the tallest ones. A few years ago now, they had a problem because they designed a concrete structure clad with stone, and it was too heavy for the existing foundations of the Sagrada. So they wanted to, they had a real problem, and they sort of came to us and see whether there could be ideas and so on. And a man called Tristram Carfrae, who's an important person in Europe, a great designer, had the idea, probably he knew the Pavilion of the Future, I'm pretty sure of that. He had the idea of using pre-stressed masonry to do directly rather than build a concrete structure and then clad it. So the pre-stressed masonry, actually that, again, it was supposed to be a video, but we'll forget it, is creating prefabricated panels made of stone and then pre-stressed so that they can be lifted in position like giant blocks in a way. There's still a little bit of concrete which is in the corner between panels. There's steel columns, concrete encased, to sort of tie the different panels because otherwise they wouldn't be tied. And they then sort of lift all of this. So again, sort of in terms of calculation, in terms of workflow, in terms of sharing information, representation, it's, I would say, state-of-the-art of what we do at the moment. Maybe not what you'll hear can be done in 10 years' time, but it's state-of-the-art what we do at the moment. But it still has to be built as well, and it still has to be proved, because the key thing about structural engineering is to make predictions that are valid. Otherwise, things could go quite badly wrong. So you need to make sure the behavior is the one that is modeled, and that the model is being achieved on the other end. And prototype, you have seen several prototypes in the talk earlier, is quite a key part of this. However, it's harder and harder to convince clients to pay for prototypes. So when you have a client like the Sagrada who has actually an unlimited flow of resource, because visitors will continue to want to visit, and they are funding the work and the development, so they have almost unlimited resource, it's slightly less difficult to convince them to do prototypes. But it is much harder in other parts of the world and industries. The fabrication is a mixture of extraordinarily precise, so machined, cutting stone in sort of very high precisions, steel milled sort of stainless steel to have a very long duration and so on. And then in terms of getting the surface, you can see the photo which is right at the top corner. The guy is still just hacking it with a sort of wedge and hammers. And that's because they wanted a sort of quite rough structure on the front to go with some of the other parts of Sagrada, and that couldn't be achieved by machines. So I think the marriage of the highly polished, highly machined sandstone that is forming the pre-stressed panels, you see one of them being lifted into position, with sort of much more low-tech old technologies, is quite powerful or quite important to continue to do. Making, you've heard about 3D printing. That is probably one step of the way, but we're very, very, very far from actually making building in one go and press print. Wouldn't it be wonderful? I'm not even sure of that. But that's, there is technologies that have been developed over years and years and years of making parts of building, parts of structures. They all have their own tools, from the sort of great piling rigs to castings to bridge bearings that are really highly delicate pieces of engineered materials, to sort of concrete, high lines. There's methods of pulling cables. This is the photo shoot of the Millennium Bridge, main fabrication pictures, Millennium Bridge in London. All of that is still on. All of that will still be happening for the next, I'll be well retired before any of this is challenged, I can tell you. A lot of building will still remain built that way. And so if we want to get some slightly more elaborate technologies in them, it might be parts of them, not the whole lot. It will probably be parts, and they'll still have to be attached. And even though the part that has been digitally fabricated will have 100% precision, the assembly will still have to contend with the lack of precision of other parts, maybe. So that's quite an important, I really, really don't believe we're anywhere near 3D printing whole buildings and that's maybe 50. It's really at the very far bottom of the hype curve. But doesn't mean we shouldn't be trying, and doesn't mean we shouldn't test it on one of the best testing ground of our activities is pavilions or installations. They have a lower duration, a lower lifespan. They are generally free of a whole number of constraints we have to deal with, like corrosion, like sort of 50-year lifespans, all sorts of other, even sometimes loads. This one is an internal one. It's so there's very few loads apart from its own weight. So we do. It's a very important testing ground, and in a way we've seen some of those earlier, because they enable you to try things, possibly not succeed quite as much as you might have liked to, but then still learn a lot about what is possible. And Daedalus is a small example of such a thing that we've been working on. And it's a slightly different take on 3D printing, which I would call extrusion printing. So it's doing the sort of wire structure as opposed to the mass or the plane. So it's a robot. It's just with a nozzle and some plastic that will just generate its wire geometry. And we did some analysis for it, but the geometry was created in one software, a bit of linkage with the calculation, but not that much. The loop of reworking the geometry to increase the density of number of elements in places of high forces was not automated, but could be. But as this was a 2-month exercise, there were certain things that were more efficient not to try to do it all again, sort of not pure. The material is PLA, which is a bioplastic. Compared properties, that's what engineers do. They need to start with some parameters, and that's pretty much the main parameters a structural engineer is interested in for his calculations. That's the bioplastic. Interestingly, actually, to make wires in a structural shape, starting with wires seems slightly devious, because we're going to melt this and sort of recreate the structural shape. Not too sure. But in terms of bioplastic, one has to watch. This is made of corn starch. But how much more cornfield can we afford to make bioplastics? How many more is the transformation applied to the corn actually sustainable? I think one has to be a bit more precise with these bio definitions than what we're doing at the moment. And I thought I'd show you a close-up, because that's where things starts to go slightly not quite as sexy as the lit, wonderful night image. And that's what we in structural engineers like to do, is to get close up. We don't, the beauty, there's always the beauty picture, but there's also what is really happening. And you can see that at the moment, in terms of buckling, for those who know what buckling is which is when an element is in compression and it has some deformation and it will just go pop. Some of those are totally pre-deformed because the plastic doesn't solidify quickly enough. So it sort of sags under its own weight. The connections are a bit haphazard, let's say, and not necessarily very elegant. The sort of thickness is very irregular at the moment. So one may question whether that technology is one that will last and get into slightly further up in the hype curve. It might not, but the idea of the extrusion might still exist and might still be used in some other form, because there's as much invention in the tool making as in the structural making. And in a way, this conference might be more about this tool innovation than sort of necessarily structural innovation. And I would really contend that if we are to look at a more immediate future for structures that are robotically created or robotically installed, one should probably start using non-biodegradable plastics, which of course, will not last much more than a few years, or maybe not even a few years if they're outside, but actually use structural materials that are already known as structural materials. And I'm thinking, for example, carbon fiber, which can be installed in densities that are very varied, which can actually be laid with machine. People making sails know that very well, that they can densify the carbon fibers in the right places. They can weave the fabric, they can weave the reinforcement. So suddenly reinforcement can also be flexible and use maybe that as probably more potential in the next few years than the bioplastics. But also it's what do we do with it? And again, the fashion industry is probably ahead of us on this front. And that's Iris van Herpen. You probably know her work. She's a fantastic designer. Again, mixing different crafts and different level of crafts together. And she has quite a good quote about 3D printing, is that you may not wish to design it just so that it looks like it's 3D printed, and you may have to have a bit more inspiration than that. And to get towards the sort of maybe the further end of the construction sequence of a project, there is the performance monitoring. We do very little of that. That is something that the industry hates, actually, because it probably wouldn't necessarily pass with flying colors on all cases. And so it's something we don't do quite enough of. And at the moment, it's probably happening more in tunnels and underground and foundation monitoring than in other fields of the industry. Although I heard that Doka, who's one of the big formwork manufacturers, is now putting moisture sensors in his concrete to be able to deprop faster. So there's various means that might occur. One project we did, which is the VNA, so that's more and more what we are contending with, building next to sort of very famous grade 1 listed buildings and trying to dig very large holes under them or very near them. And this is probably the closest you'll see a pile being realized next to a historic building for a while. It's less than a meter to the historic building. And then the whole thing was propped on stilts and to create the space which is in the middle, which is just been recently opened in the VNA. That, again, a lot of analysis about ground movements to enable, so these are sort of multi-million element calculation models done by geotechnics and structural engineers, and they sort of predict how much the Earth's movements are likely to be. All well and good, but do they actually move that much? And so what we did on the VNA, which is not that frequent, is we instrumented some of the piles with measurement devices in order to make sure we could check what the behavior was. And the thing which is happening in instrumentation at the moment is real-time instrumentation. Not all of the VNA was real-time, but some of it was. And real-time instrumentation is quite interesting because it gets to trigger levels. So if suddenly something goes beyond a certain number, suddenly you get your client calls, or your contractor needs to call, and it cascades to a number of people, and there's a number of action that need to be taken. And we are not doing real time on VNA, so that's more like every 2 or 3 days they take the measurements. But on the project in the Claridge, we're doing a large excavation under the Claridge. That's real time, and one of our engineers got woken up at 3 in the morning because somebody had shaken the instrumentation thing. So suddenly there was kind of large movements, large vibrations, but it was nothing to get alarmed by. So again, technology that needs to evolve, and the attitude of people towards the results and how we deal with the results have to. But the results measurement in real time are all processed. It's all automated, and it sort of goes back. The emails go to several people if it exceeds the capacity, alerts, and so on. And that's what we're going to use on the project that I'm working on at the moment, which is above the main tunnels of King's Cross. Project itself is not particularly earth-shaking, but what will happen with the monitoring will be quite interesting. And we also equipped a few piles with fiber optics to do some research more about, again, validation of models, but more and more research-based than just purely to produce the thing. We do a lot of vibration monitoring in building, notably with CLT. CLT is light. It tends to vibrate more than concrete slabs. So we do quite a lot of that. And now we've got a vibration monitoring app. I haven't personally used it, but I want to lay my hands on it. I think several people have said it's quite amusing because we've all probably prepared our presentation in a different world and in a different sort of context, but with the preoccupations of because we can doesn't mean we should, you know. And I think I want to give you a structural example of what that could mean. So I've worked on the Centre Pompidou Metz. It's sort of grid shell timber, and it's quite an extraordinary grid shell and timber. The project of a lifetime, or the nightmare of a lifetime, for a structural engineer, if you want to. It's used all the possible methods and technologies available: CNC, calculations, prediction, parametric modeling of the geometry so that you could cut the elements at the right length so that they didn't have their torque more than 3 degrees to the grain. I mean, sort of, you know, really sort of elaborate mathematics went behind this project to make it happen. And I have always liked to sort of see what happens afterwards. And a friend of mine in Japan, again in Arab, worked on the Gifu library. And they took the anti-Pompidou Metz attitude. They said, we don't want to use CNC. We shall design this so that we don't have to use CNC. And they've developed the geometry so that it could be made of flat strip that would just bend into place. So they would just, they're not being forced, they're not being cut into shape, they will just droop naturally on the shape. But the shape, of course, is not generated in the same way as the shape of Pompidou was. That one was generated so that it was possible to droop the elements and to have the right sort of tessellation and so on that shape. So I think that when we go back to economies of means, that is for me more economies of means than the sort of Pompidou, which is all the extraordinary, as sort of was using the technology a bit with like brute force. This is probably a more subtle use of technology. And then there's less technology again, is my colleagues at Hook Park are doing, and they decided to try and create a structure. This is a wood chip barn, which is made from not even, well, cutting the trees, but not very much. So just using the branches as the connection almost. So there's a degree of all of this. So even though we will probably be able to do this in a not too distant future, does it give what we need, or do we already have the ideal material? I would ask the question for structures. Also, will ever additive technology create this? This is the Nacher Gallery stone in Texas, in Dallas. Who will ever program a 3D printer to create this? And I think that's where what we do tends to oversimplify life and is lacking in perfection. That's we can. Just that little nick of the concrete, beautiful, creates the light. You suddenly look at it and it sort of catch it. If you had 3D printed it, it would have no defects. It'd be perfect, but is that still life? And then the last thing we shouldn't forget is why we do this. We don't do this because we want to sort of have new tools. We don't do this because, although there is a human drive for new technology, don't mistake me, this is a very human thing to create new tool for itself. But we have to think about the places we're creating. And sometimes it's not even the structures that create the place. Again, economies of means. Arup must have worked at least 25 years on the whole King's Cross regeneration area, and it is now visible. A lot of what we've done is not visible. It's in the ground, it's in changing the tube, it's in changing other parts of the infrastructure. It was not necessarily done with digital tools that much, but it has created one of the best regeneration places in London out of what was the crack den of London. You know, King's Cross, when I went to London, was just a place you wouldn't go. And now it is one of the hypest, best places, and you can see what happens in the summer. There's a lot of parks and new places that have been created. Some reuse of old structures as well. And so don't forget that when you get in life and do your things. We are rearranging nature, and so it is quite precious what we do with it. And instead of worrying whether human beings will be superseded, I think materials will be superseded before human beings. Thank you.
Thank you very much, Sophie. We have time for one or two questions.
I'm so sorry. Just wanted to ask about this arenas, this stadium, and you talked about the simulation of wind forces, and you said something that this wind forces must be more high-res resolution. So you really advance in this construction thing. Can you just explain more about this resolution? How much is it?
Yeah. When you do shapes that are a bit unusual, and even a dome is still probably considered slightly unusual, and especially of that size, you often do what is called a wind tunnel test. And the wind tunnel test has got a whole series of sensors that are placed on the surface that measure the pressure at any point in time with wind directions. You move the model, and so you measure with the wind in all sorts of direction, and you measure the pressure on top, the pressure below the surface generally, and you generate this enormous mass of data which has been captured in real time, so you actually know what is happening at the same time. So you know that this pressure with the pressure below is concurrent with this pressure and the pressure below on another part of the structure. However, with the sort of capacity of computers of yesteryears, you had to sort of simplify this mass of results into much, much simpler load cases. So you would say, okay, this whole area will be within sort of suction area. This area is going to be pressure down. This is the order of magnitude. Now you're able to actually use the real-time data, what they call time history, in order to do analysis for all the directions of the wind in real time. So you have the real wind, not a sort of over-enveloped sort of calculation of what the wind is. And that's the main difference. We do that with seismic as well now, for tall building in particular.
So this is a question, again, related to the whole time history analysis of both buildings and the dome and so on. They produce vast amounts of data. Do you then use them as a single shot and you perform the analysis and then you get a result? Or do you then look through all the studies and then try and use that to inform a potential optimization of your structure?
No, you're quite right. This is not, especially in the case of the stadium, this was not used as a single shot analysis. So you do your first runs. It tells you where to distribute, where it's you need more material and less material, and then you reiterate until you reach a sort of equilibrium. And it's a sort of virtuous circle, because as you are able to shave material off, then it gets lighter, and it actually sort of does have less weight to carry, therefore it has less forces often. And as often in large span structures, weight is the governing factor. It's the dead load of structures that sort of governs. So being able to do that sort of iterative loop, and you can do that also with connections, so you can start to put also criteria related to connections. The mass of data being generated by these analyses is not post-processed manually, because that is well beyond the ability of an engineer to do so. So it's also automated, the post-processing, and often turned into, I mean, I showed you the force map for the analysis, where we generate force maps, but it could also be a map which shows which connections fail. So you do a yes-no criteria in entering the sort of connection capacity, and so suddenly visually you can really very, very quickly have a feel whether you have improved from the previous one or not, without having to sort of really plow through the data. So you use a lot of automations of post-processing as well.